Hey, geometry kids, 2.6 is where we're at right now, and we are on page 61 of your student journals. All right, we are going to talk a little bit about a couple different kinds of proofs. So in this section in your book, if you looked, it talks about flowchart proofs and paragraph proofs. To be completely honest with you, I'm not going to go over those. And so I'm going to do all proofs as a two-column proof. So when you are looking in the book and you want to look at flowchart proofs and whatever, that's fine, and they're fine. I just, we're going to kind of simplify things a little bit and just kind of focus on two-column proofs. All right, so I'm going to do a couple different proofs together, and then we are going to just do them as two proofs. So we didn't give you the actual, diagram for the proof. So I'm going to have you guys draw it all out, or me actually. And so you're going to draw the kind of like a large capital T, and you're going to write statements, and you're going to write reasons. So what we're trying to prove is that all right angles are congruent. So I didn't even give you a diagram. So let's go ahead and draw. I'm just going to draw a diagram of a right angle. I'm going to label this as angle 1, and then I'm going to draw another diagram, and I'm going to label it as angle 2. And the reason I'm doing this is just to help make things a little bit easier as we record things in my proof, okay? So let's start with what we know to be true about proofs. First and foremost, we go ahead and start with our given. So I didn't really give you a specific given and proof. So what I told you is that all right angles are congruent. So statement number 1, we're going to say what we're provided with is that angle 1 and angle 2 are right angles. And this is my given. So angle 1 and angle 2, I'm supposed to say are right angles. All right. So that's kind of where we're starting, right? So that's my diagram that I gave you, and that's kind of our starting point. So what do we know about, if something is a right angle, what do we know? Well, hopefully we know that the measure of angle 1 equals 90 degrees, and the measure of angle 2 would equal 90 degrees. And the reason I know this is because that's what the definition of a right angle is. So definition of right angle. So by definition of right angle, we know that they have to equal 90 degrees. All right, so what I know is that if angle 1 equals 90 degrees, and then 90 degrees equals angle 2, what I can say is since both of those things are equal to the same value, I could say the measure of angle 1 is equal to the measure of angle 2. And how do I know that? Well, that's that transitive property. Remember, when two things are equal to the same thing, they have to be equal to each other. So transitive property. Our goal here, which isn't quite obvious, what we're talking about here is we're trying to, whoops, and I used the wrong here. Ignore that. It's supposed to be just equals, not congruent. All right, so our goal is to show that all right are congruent. So we have to end by saying that these angles are congruent. So this is representing all right angles, right? We just drew a couple right angles. So now this is kind of the opposite of what we did in our last video. We're now going to go from equality to congruence. Because remember, our goal here is to prove right angles are congruent, not equal. So I know that if two angles are equal, then they have to be congruent because that's the definition of equality. Or we can say definition of congruence. I would take either, actually. I kind of like definition of congruence better. So that is your proof, kind of start to finish, of I can prove that all right angles are congruent. And so what we just did is we proved Theorem 2.3. So Theorem 2.3 states that all right angles are congruent, and this is the justification why. So this is the reasoning why we know that those angles have to be congruent. All right, let's do another one. So now we're going to talk about Theorem 2.4. And this one is congruent supplements theorem. And so what this theorem states is if two angles are supplementary to the same angle or to congruent angles, then they are congruent. So it gives me a diagram. If angle 1 and angle 2 are supplementary, So remember what supplementary means, adds up to 180. And 3 and 2 are supplementary. So 3 and 2 are supplementary. Then angle 1 must be congruent to angle 2. I'm sorry, angle 1 must be congruent to angle 3. All right. Let's do a proof. Start with your T-chart and your statements and your reasons. All right, let's go with what we know to be true. So in our first thing, I know that angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary. So I can say angle 1 and angle 2 are supplementary, and I'm going to say angle 3 and angle 2 are supplementary. And that was our given. So we have to use the given next. So what do we know about supplementary? What does it mean to be supplementary? Well, it means it's up to 180 degrees. So what we're going to say next is we're going to talk about the measures, because remember we're talking about how they add up to 180 degrees. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And then we can say the same thing, the measure of angle 3 plus the measure of angle 2 equals 180 degrees. Why do we know that to be true? Well, we know that to be true because that was the definition of supplementary. Okay, so notice here, if measure of angle 1 plus the measure of angle 2 equals 180, but then 180 equals the measure of angle 3 and the measure of angle 2, we can kind of bypass that middleman and say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. This is that transitive property again. Notice how we use this quite a bit. So again, two things are equal to the same thing, they have to be equal to each other. Our goal is to show that angle 1 is congruent to angle 3. That is our goal. So statement number 4. What can I do here? Well, if you notice, they both have an angle 2 in common. What if I subtract that from both sides? Then I would get measure of angle 1 equals the measure of angle 3. And this is that subtraction property of equality. Now we're in the home stretch. One more statement. We already know that their measures are equal. How do we say that they're congruent? Well, we know that angle 1 is congruent to angle 3 by definition of congruence. And that would be your proof for that particular theorem. All right, we're going to skip around a little bit. So I'm going to move you now to Theorem 2.6, very bottom of page 62, very bottom of page 62. So all the other ones we're going to use, I'm going to use one as like a warm-up maybe, and we'll maybe do some of them in class, but I'm going to jump ahead to this one. So Theorem 2.6, it says vertical angle congruence theorem. All right, let's draw our proof. Feel free to do this on a separate sheet of paper if you don't like to, write it all in here. All right, so our goal is to prove that vertical angles are congruent. So we're given a diagram, angle 1 is congruent to angle 3. That's our goal, and prove that 2 is congruent to 4. So those are vertical angles, and we're trying to prove that they're congruent. Okay, so let's start with what we're given. So in the theorem, we are provided that angle 1 and angle 3, so in this diagram, we can conclude that angle 1 and angle 3 are vertical angles. And we could also say that, 1, 3, and 2, and 4 are vertical angles as well. I don't know if we need that though. All right. What else do we know in this diagram? Well, in this diagram, I know that if I put 1 and 2 together, what does that form? Well, it forms a right or a straight angle, which means that those measures are going to be equal. So the measure of angle 1 plus the measure of angle 2 has to equal 180. Okay. But then if I put 2 and 3 together, this way happens here. If I put 2 and 3 together, this also forms a straight angle. So I can add that to that same statement. Measure of angle 2 plus the measure of angle 3 equals 180 degrees. And the reason I know this is because that's what a linear pair is. So it's definitely a linear pair. I would even take straight angle, like definition of a straight angle. Okay. We're trying to prove that angle 1 is congruent to angle. So on the next statement, I'm going to say, well, if these two things are both equal to 180, then I know that the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle 2 plus the measure of angle 3. And that's that transitive property we keep using. So now I'm going to say, kind of like that last proof we did, I'm going to subtract measure of angle 2 from both sides. So I get the measure of angle 1, not congruent, is equal to the measure of angle 3, and I'm running out of room here. And that was that subtraction property of equality. And now I can end my proof by saying angle 1 is congruent to angle 3 by definition of congruent angles. And the reason why is because I said they're equal, now I can say they are congruent. Well, since we already knew 1 and 3 were vertical angles, now we just prove that they're equal. So therefore, we prove that vertical angles have to be congruent. And so this would be kind of my, proof for that particular theorem. All right, so there are other proofs obviously in here that we're going to kind of go over and maybe use them in class, but also for your reference as well. I encourage you to keep practicing proofs because the more you do, the easier it becomes. All right, if you have any questions, bring them to class. Thanks.